Dear students, in this video we are going to see the remaining topics in module 2, that is linear time invariant system. How to find the response of the linear time invariant system. We have two different methods already last class we discussed, that is convolution sum and convolution integral. In this video we are going to see convolution sum. What is convolution sum? We know that to obtain the output of the digital system, that is nothing but to obtain the response of any impulse function, we are going to use the convolution sum. So in that we are going to consider the input x of n, x of n of the x of n from the knowledge of the system. Impulse response is h of n. So here we are going to consider the input is x of n, that response is h of n, and output of that one is y of n. So this is the simple block diagram of convolution sum. Convolution sum, impulse response we are indicating as a h of n, and input is x of n and output is nothing but a y of n. Now impulse response. So impulse response h of n for LTI system, linear time invariant system. So consider the input. Now we are going to derive the how to find the output response of this impulse response y of n. So for that we are going to consider the input x of n. Input is x of n is equal to x of n. So you know impulse response, that is nothing but impulse function is delta n. It is 1 for n is equal to 0 and remaining values it is 0. So now x of n is equal to so if you substitute 1 means x of and so on. Now I'm going to substitute x of 1 into delta of, so convolution of these two, it is nothing but x of 1 into delta of n plus 1, next plus x of 0 into delta of n, plus x of 1 into delta of n minus 1, plus x of 2 into delta of n minus 2, plus x of 3 into delta of n minus 3, and so on. So summation of these two will get the response of h of n. So that one that system response will give the output y of n. So output y of n is nothing but this x of n in x of n and x of n convolution of this impulse response h of n. So now how will get the input? Input x of n is nothing but x of input into that impulse function, that will give the impulse response h of n. H of n into x of n convolution will give that corresponding output y of n. So y of n is equal to if you substitute minus means x of minus 1 into h of n plus 1, plus x of 0 into h of n, x of 1 into h of n minus 1, plus x of 2 into h of n minus 2, and so on. Same thing what we used for the first one, same thing, but here we are convolving input signal into delta impulse function to get the impulse response h of n. Once if you know the impulse response h of n, that input and h of n convolution of the impulse response h of n and input x of n will give the output of this system. Now an input x of n, so that we are going to write it as the previous equation. This whole thing we can write it as summation m is equal to 0 minus infinity to plus infinity x of m into delta of n minus m. So that instead of writing all the summation, we can write it in the summation summation x of m into delta of n minus m. Now same thing if you write in our output equation also, output equation y of n is equal to summation m is equal to minus infinity to plus infinity x of m into here h of n minus m, So the same thing here, it will give us the input. This is a simple block diagram of impulse response for the time domain analysis. Now the impulse response, we can say that impulse response is we are indicating as a h of n for the linear time invariant system. You know, linear time invariant system is nothing but the system should satisfy the linear and time invariant property. Such a system we can call it as a linear time invariant system. So that convolution of x of n, h of n, and to input x of n. So impulse response h of n, convolution of input x of n will get the output of this system. That is only y of n is equal to x of n into h of n, So now by output is equal to convolution of input x of n and impulse response h of n. We can write it as a y of n is equal to x of n convolution. This symbol gives the convolution of h of n. Now the method. So what are the methods we can use to find this one? So methods of evaluating the convolution sum. How to find the convolution sum? So what are the methods? So now given the system impulse response, so we are going to construct the impulse response h of n and input x of n. The system output is y of n. Using the convolution sum, y of n is equal to the same thing what we written. Y of n is equal to y of n is equal to convolution of input and impulse response, that we can write it as a summation m is equal to minus infinity to plus infinity x of m into h of n minus m. So this is nothing but a convolution of input into impulse response. So by using this formula we are going to find the convolution sum, and remaining problems we'll see in the next class. I hope you understood.